Take second example. Again, we want to classify the singular points of the differential equation x square minus 1 whole square y double dash x plus 1 y dash minus y. Now we write a2 of x. First we find what's our singular points. a2 of x is x square minus 1 whole square. Now for singular point, we are having a2 of x is equal to 0. That means x square minus 1 whole square equal to 0. I will get here x minus 1 whole square into x plus 1 whole square equal to 0. I get here 2 points, x equal to minus 1 and x equal to 1 are singular points. Because on these points, we are having here the value of a2 of x equal to 0. There are 2 points, they are singular points. Now this is my step 1. Now step 2 is to check they are singular, points are regular or irregular. Now we are having x0. Now x0, I take it x0 is equal to 1. And I check this point is regular or irregular. I have to multiply, I have to identify my p of x before doing that one. So I normalize this one, I divide my whole equation with x square plus 1. I get here y double dash plus. We get here x plus 1 over x square plus 1 whole square. We can write here x minus 1 whole square into x plus 1 whole square, and the plus we divide this one also minus 1. Here is minus 1. Divide by that, we get here x minus 1 whole square into x plus 1 whole square y. Here is y double dash, y dash is equal to 0. So that gives me p of x. My p of x is equal to is 1 over x minus 1 whole square into x plus 1. So I have 1 x plus 1 is cancelled with this square, and we get here only. And then we're having q of x. Q of x is equal to minus 1 over x minus 1 whole square into x plus 1 whole square. Now we are in position that we can check that this is where I take step 3. Step 3 is I want to check this x equal to minus 1 or x0 equal to minus 1 is my regular singular point or irregular singular point. So multiply my p with x minus x0, that's x minus become plus into p of x, and if I multiply here, I'll get here x plus 1 over, we are having here x minus 1 whole square into x plus 1. So x plus 1 is cancelled to x plus 1, we get here 1 over x minus 1 whole square. Then this is number 1. Number 2, we're having x plus 1 whole square q of x. So that gives me here minus x plus 1 whole square over x plus 1 whole square into x minus 1 whole square. So I change it here minus and we put it here plus. These are cancelled and we get here minus 1 over x minus 1 whole square. So we take here at x equal to minus 1, we're having x plus 1 p of x, and we're having here x plus 1 whole square q of x are defined. I will say are analytic, which implies x equal to minus 1 is a regular singular point. So that's here, it's number 3, that we check x equal to 0 equal to minus 1, that there are 2 singular points that x equal to minus 1 and x equal to plus 1, and we have taken this one first, and we check this one about is this point the regular singular point, and we got it that x equal to minus 1 is regular singular point because this is the rational function defined at x equal to minus 1 as a rational function defined at x equal to minus 1. When they are defined, they are analytic. When they are analytic, so they are regular singular point. Now I take here the last case, number 4, and we check here x equal to 1 as a regular singular point or irregular. So we get here x minus 1 p of x. So that will give me this equal to x minus 1 over x plus 1 x minus 1 whole square into x plus 1. Simplify this one. We get here 1 over x minus 1 into x plus 1. Now at we see here at x equal to 1, x minus 1 p of x is not defined. Is not defined. When it's not defined, we say x equal to 1 is irregular singular point, because if any one of the function is not defined, it means it's not analytic. When it's not analytic, that means this is not a regular singular point, it's irregular. We don't need to check the second one, because any one of them, when it's not analytic, we say this is not a regular singular point. So this was our equation. First we find the singular points by putting this value equal to 0 using this one. When equal to 0, we get 2 points, x equal to minus 1 and x equal to 1. They are singular point. Then we check they are regular or irregular. So first we write our equation in the form, they normalize this one, make this coefficient 1, find p of x and q of x. We found here p of x, we found here q of x. Then first we check here x0 equal to minus 1. So multiply by x minus x0 become x plus 1 p of x, and then x plus 1 whole square q of x. So I get this function. Now I know this function is defined at x equal to minus 1. Also this is defined and this is equal to minus 1. We say they are analytic. If they are analytic, then the x equal to minus 1 is regular singular point. Now next is x equal to 1. When I take x equal to 1, x0 equal to 1, multiply by x minus x0, that's x minus 1, p of x, and here when we simplify this one, we get 1 over x minus 1 into x plus 1. This is present in the denominator. So when we take x equal to 1, this will be 0. So it says it's not defined at x equal to 1. Not defined at x equal to 1, none is mean the point will be, it's not analytic and point will be irregular singular point. We don't need to find the second part that x plus 1 whole square q of x is analytic or not, because one of them is not analytic, it means it's not regular singular point, it's irregular singular point. I have more examples in the notes, and my notes PDF file I'm putting in my description, the reference, the link for that one. You can copy the note and you can see some more examples and some more details about the regular singular point and irregular singular point. At the same time, I would like to mention that you subscribe the channel and press the bell icon, like it, so that you get the notification for that one. We will be continuing for the higher the studies on the differential equation. I'm going to add also the numerical solution of the differential equation, and then after series solution we are having the Fourier series, and more topics we're going to cover for the differential equations.